Now, these lectures will continue to introduce the stiffness methods and its application for analyzing of the plane truss that's are shown here. Now, the last week we have completed this topic, introduction, stiffness methods, and we are doing these examples from the last week that I'm going to cover it today. We done all these exercise with you. You can check the lecture recording if you miss last week one, but we have completed all these ones, and we have obtained this simple big kind of a matrix that will be used to the getting the frame matrix. And then we solve these examples. If I open that OneNote and I can show it to you that we solve that. You can see we solved these ones and we got all these we got this K value. Now, since the last weeks, we are trying to get this K value in our Excels. That's what we left last week, and I'd like to continue these ones in first 15 to 20 minutes. So I think we finish here. As you can see, this number here. Now, if I come back here, number 4 and in here, so equal to, you can see bracket in here, AE on L minus 12 EI on L cubed minus 12 EI on L cubed, bracket lambda x lambda y times lambda x times lambda y. So that's all good. And the same things we need to put it here because that is symmetric, if you remember that. So that's all good here. And we can have 6 EI on L square, 6 EI on L square times by lambda x, and that would be minus lambda x. So that's all good. And we put the same thing here, Control C, and the same number goes here. Then we have this part here, AEL lambda x square. So equal to bracket AEL times lambda x square plus 12 EI on L cubed plus 12 EI on L cubed. Sorry, this is lambda y square, by the way. Lambda y squares and then lambda x squares. So you need to be careful when you develop that one. Sometimes it triggers some error, and that would be this one, 6 EI on L squares minus 6 EI on L square times by lambda x times by lambda x. So what we done here, that would be lambda y. That would be lambda y, and that's not the minus. And 6 EI on L square lambda y. So in here, lambda y, and that should be not minus. Okay, so that's all good. Last one equal to minus 6 EI on L square. 6 EI on L square. Sorry, this is a little bit boring for you, but this is how it is. It's help you to develop this kind of matrix. And last one, 4 EI on L. 4 EI on L. That's the 4 EI on L. So I think once you develop this matrix, we need to get how big the matrix. That's what's the total degree of freedoms for these ones. You can check it, or we can check it from that examples. Yeah, so you can see here. You can clearly see here that all these has how many total degree of freedom? Total 9 degree of freedom. So we need to get the 9 by 9 matrix. So element 1, or we can have a K1. Let's put the K1 here. And we need the 9 by 9 matrix 1. And then you can put 2 here. and you can just scroll it down 3, 4, 5, 6, 7, 8, and 9. So that's done. 1 and 2. This one's here. 3, 4, and 9. Now we need to get it here. 1, 1. So this one 1, 1. 2, 1. So probably we can just drag it here. So you can see 2 and 1. That is perfect. 3, 1. Column 3, row 1. That is perfect. So we can just make it in that presence and make it in the middle. Okay, so that's all good. Now 4, 5, and 6 are 0 because there is no any columns for that. So that is all good. 4, 5, 6 are 0. We can drag it down here. 4, 5, 6 is 0. That is perfect. And I think this one also need to be up to 3, right? Because you can see row 1, 2, and 3. So 1, 2, 3, 1, 2, 3. So you can check this 3 by 3. So that is perfect. I think 4, 5, 6 are 0. So let's get 0, 0, 0, and 0, 0, 0. And then if you just 1, 2, and 3, 4, 5, 6 are 0. So we need to fill those gaps here. 7, 8, 9, and 7, 8, 9. So that is a chunk here. Is 7, 8, 9, 7, 8, 9. So if I do it 7, then I can just 7 and then 9, 9. So you can check 9, 9 is there. Okay, so it's quite simple to fill. 7, 8, 9, 1, 2, 3. So 7, 8, 9, 1, 2, 3 is here. So that's fill here. You can go across and come down. Row 7, column 1. So column 1, row 7. So there you go. And then you can just goes across and go down. Okay, so that is your 9 by 9 matrix for K1. Now for K2, we need to do the similar stuff. We can copy these whole things, Control C, and let's make it somewhere here, K2. And that is K2 and element number 2. Sorry, this is boring for you sometimes, but yeah, I can't make it more than this entertainments. We need to go through this process. So I think this is a near node 1, 2, and 3, and then 4, 5, and 6. So that is our notation 1, 2, and 3. So and then 4, 5, 6, and 1, 2, and 4, 5, 6. So that's easy. Now we just need to do it exactly the same. These things need to be go here. This thing need to go here, and this. So these numbers. No, sorry. When you click here, you can't drag it. I think these ones like this. Yeah, once it's turned to this face, you can just drag it for the number 2. Right. So now here you can also drag it. I think it's dragging for these all these numbers here. There is nothing I can, as I mentioned, nothing I can make more entertainment this ones. But once you've done this exercise, it's required for one time. And if you change those numbers, it will automatically change. So carefully done it first times, and then it will work for every time that you need to do it. So it's just a business of dragging these numbers for the number 2. If you have any faster ways, and if you know any Excel tricks, share with us. Some students may have experience working from their undergraduate degree or from industrial experience to do the Excels. So then you can do it something faster as well. So yeah, you can keep an eye on these numbers that here. that these numbers need to be corrected, because you know the symmetric, right? All these row that become columns. So you can see that these numbers would be quite similar. So that's all good. We can drag it and we can match. We can going to do the verifications with the hand calculations too. So we will see that if it is working or not. So let's put this one all in, and we do the verification with the hand calculations. For the Excels, the good part is always give you some visual indicators. You can see whole problems into the one screen, right? Rather than writing everything up. So that's the good part of it. It is very interactive. As you can see the numbers. You can see where these numbers are coming from. If you make a mistakes, you can still see the visual effect of that. Visual effect for that one. So you can see these numbers are behaving quite nicely now. Nothing so much surprise on here. If any surprise comes, we have equations here where we're going to match it with these numbers here. So yeah, it's quite going faster here. A few more lines to go. Stay with me. I know it's kind of boring sitting on the front of screen and watching me to move these ones, but believe me, it would be useful as you going to watch these ones, and when you do it by yourself, it would be useful. So when you do your assignment, sometimes with the hand calculations, it would be quite challenging and it cause some errors. So if you have a backup with the Excels, of course, it would be useful. And most of the engineers in practice use the Excels heavily. So we also encourage you to use Excels, but for your assignment submissions, you need to perform the hand calculations, because in the exams, you're not allowed to use the Excel. So Excel is used for learning the concept and comparing your answers with that one. So you don't feel that you don't have any tools to understand your enhancing the skills. So it is better that if you can use those tools here in the Excel. So I think it's the second lowest row. We are getting there. So just hang in there for just a few more minutes, and we supposed to be finished in a 3 minutes time. So we can start working on our main topic. So it's the second last row. We are finishing soon. I think we are getting it very close now. Yeah, just moving these ones for the element number 2. I hope it is makes sense what I'm doing. Put in the questions in the chat. Once I finish this ones, I will going to answer. Okay, so that you will. If you make a mistakes, undo button is there, so you can go back and check it. So that is the last one, lucky last row that we are finishing. Check the while you are watching the screen, check whether I done the correctly. All the rows are matching with the columns or not. Just check it with those numbers. If there is any discrepancy, just put it in the chat. So we have it here. We have it here. And we have it here. So that's all good. Now you can look at these numbers are coming it up in the good shape. So that's here, here, here. Okay, that looks good. And then once you've done these once you've done these ones, you can also do K2, and you can do it in that fashion. So let's copy this one here. We will not going to take it this one, but the one let's get one here and look at the magic. 1 2 5 1 2 6 and 1 2 6, and from here that would be 0. So that's 0, and this all the way here is 0. and here C1 is 0, and we just going to make it C1 0, and we scroll it down. So you can see all 6 by 6, 9 by 9 is there. And if you want capital K, that would be your small k1 plus small k2. You will get just simply by doing this. Very simple. All right, so you can see we want this guy 1 plus this one. And bang, this is the magic happens very quick. Look at this, bang, right? So quite useful. So you can see these numbers are behaving correctly, so that looks correct. This 1 2 2 5 0 minus 5 0 0 minus 11, yeah, it's symmetric. So all these numbers here is same as these numbers. You can see that. Similarly, all these numbers here is same as these numbers. All these numbers here, all these numbers here are same here, right? You can watch it. And these numbers here is same as these numbers. And similarly, these numbers here is same as these numbers. These numbers here is similar to these numbers, right? So it's behaving quite nicely with us. Nothing so much surprise. These numbers are here same, and these numbers, let me put some different number. These numbers are same. All diagonals here, 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 white one is all positive. So that's again one more correction. So this is the exercise to get the capital K for the frames. OK, we done the hand calculations as well. So if you can look at the hand calculations here, that's hand calculations, I think 5.11.25 10 to the power 6 is similar. Yeah, 5.11. You can see that is similar. 0 22.5, 0 22.5 similar, right? So hand calculations are matching with this one. 789 is 789 is here. OK, so any questions so far to get the capital K? You know, this is the problems we are solving. I think the question is we need to find. The question is we need to find that determining the reaction of the supports, and all the details are given there. Right, so we need to find the reaction forces. So what the process is, we done the process. I can summarize. Let me turn off the camera, and the process is, I hope you can see the screen. Now I can remind you that process is we need to get the small k1 for member number 1. That's we already done. We can get the k2, that is for member number 2. That's we already get it. Third, we get capital K equal to k1 plus k2. That's we done. Now the next one we're going to do it is to get the displacement matrix and the Q0 matrix. So let me get the equations for you. So let's we get the Q0 matrix, and then so the finally we're gonna do it K equal to KD plus Q0. That's the equations that we're going to use. We already found this capital K in the step number 3 here. Step number 3, we found this capital K. Now we can get the capital Q. We can get this capital Q. We're going to write 1, 2, 3, 4, 5, 6, 7, 8, and 9 because we have total 9. Now, if I go back all the way top and get that equations, get that figures here. If I get that figures, here you go. The figures are here. And if I can put it here, then we can see it. OK, so in here we have we have this is fixed supports. So by the way, this is fixed supports and this one is fixed supports too, right? So total degree of freedoms, total degree of freedoms equal to 9. Now out of total 9, how many free degree of freedoms and how many fixed degree of freedoms? So you can see this joint number 2 is free. So I can see that 1, 2 and 3 are free degree of freedoms. 4, 5, 6, 7, 8 and 9 are fixed degree of freedoms. So I can draw the line here to just make a division between the fixed and free. Now, when you have 1, 2 and 3, there is no any force. You can see there is no any force in the 1, there is no any force in the 2, there is no any force in the 3, right? So all 1, 2 and 3, there is no any force. So that's, let's put those 0. Do you understand that, right? So if you look at any force, there is no any force is going in here. There is no any force in going here. There is no any force going on 3. So these are 0. Now Q4 meaning that there is a reaction force that we need to find. Q5 there is a reaction force because fixed support has a 3 reaction force, and on the 6 there is a Q6 reaction force. Similarly, Q7 has a reaction force, Q8 has a reaction force, and Q9 has a reaction force. So basically, when you make a Q matrix, free is the one that you're going to look at if there is any force. All the fixed one you just put Q4, Q5, Q6, Q7 without looking that one. So it's a fixed and free. Any questions in the any questions the force vectors? This one is the force vectors, by the way. The next step is to do the D. D is quite simple as Q because you can have 1, 2, 3, 4, 5, 6, 7, 8 and 9. In that once again we can draw the line which can make it this one is your free degree of freedoms and this one is your fixed degree of freedoms. Now your free degree of freedoms, that's your unknown, so you can put displacements and you put those are 0, right? So quite simple, which is opposite to your Q matrix. You can see in the Q matrix you have those 0, 0, 0, 1, 2 and 3. In your D matrix, this is D1, D2 and D3. This is opposite. And 4, 5, 6, 7, 8, 9 is your unknown value, but here 4, 5, 6, 7, 8, 9 is your 0 values there. So any questions in finding the D matrix? Q and D matrix, all good? We are we are moving slowly on completing these examples. So here we are. How the progress is going? Q equal to K D plus Q0. We got these equations. We got these equations. We got this equation, and now we need to get the Q0 matrix. That's I'm going to try to make it. So let's grab the again these figures. Very important figures from our questions, and I will explain you that how we're going to develop the Q0 matrix. So let's paste it here. So this is our figure. Now, to develop the Q0 matrix, we need to work in the 2 members. If it is 3 members, you need to work in for 3 members. So let's get the member number 1 first. These numbers with the square representing that is a member number 1. So let me draw up the member number 1 first. So member number 1 look like this. And for this case, we have a node number 1, node number 2, and we have 7, 8 and 9, and we have 1, 2 and 3. So that's 7, 8, 9 and 1, 2, 3. I hope it is makes sense. And we have a loading of 12 kilonewton per meters, right? We have loading of 12 kilonewton per meters. Now, when I draw it up these ones, notes and use these tables. I think it's in the slide number 17. If you go on the slide number 17, there is an equations to calculate forces, right? So that's pretty much simple. So you can come back here and let's paste it here. Let's paste it here. So by looking at these ones, by the comparison, I can see that this force here this force here is WL square on 12, and this force here would be WL by 2, and this force is WL by 2, and this force is WL square on 12. Now what is this green force? Now this method, stiffness method, does not like that the force is coming onto the members. This stiffness method does not like that these force are coming. So it likes, so when you have this frame given to you fixed, it likes when the force is here, here, or here. It does not like when the force are coming on here or here. This does not like. When you have force when the force is applied onto the members, it does not like it. It does not work. So we have smart way to do it. That how about whatever the force here, we're going to transfer it to the node. Right. So what happens here? We are going to basically transfer this load. The length is basically 4 meters here. So we can substitute 12 kilonewton per meters times by 4 meters over 2. So that will give me 48 over 2, 24 kilonewtons. Similarly here, 12 kilonewtons per meters times by 4 meters over 2, which gives me 24 kilonewtons. In here, W is 24 kilonewtons per meters. Length is 4 square meter square over 12. So let me use my calculators. So 24 times 16 divided by 12, you get WL square on 12. Is it correct? Yep, WL square on 12. And that's not 24, that is 12. So that is 12. So 12 times 16 divided by 12, you get 16 kilonewton meters. And similarly here, we got 12 kilonewton per meters times by 4 square meter square over 12, so 16 kilonewton meters. Now we got everything here, so we can develop Q0 matrix, Q01. Let me get this one a little bit down here, so I can work on Q0 matrix. So here you have these figures. Q01 equal to, we can have a because you can see this arrow is here. This arrow is telling me this is a near node and this one is far node. So for that case, 7, 8, and 9, that is a near node X, near node Y, and near node rotations. And here far node 1, 2, and 3. So what is the force in the 7? That is 0. There is no any force in the 7. What is the force in the 8? 8 is 24. So 24 kilonewtons. What is the force in the number 9? There is number 9 and it's going in the same directions anti-clockwise, and that is 16 kilonewton meters. So positive 16 kilonewton meters. Similarly, there is no any force in the 1, so that's 1 is 0. There is a force in number 2. How much is 24 kilonewtons? So 24 kilonewtons. How much force in the 3? So there is anti-clockwise, but this one going clockwise, so that would be minus 16. I hope you understand this clockwise and anti-clockwise is opposite, because this is positive. Number 3 is positive when it goes this way, but our actual one that is given in here is opposite to one that we have. So therefore it is minus. So that is a Q01. Now similarly, we can do the member number 2. Member number 2, I can give that figure again to draw it up. If there is no any force is applied, then you just take it, those are 0. So for examples, for this member number 2, which I'm going to draw it up here, this one, which is member number 2, arrow is going this way. 10 kilonewton is applying this way. And we have this 1, 2, and 3. And you have these 4, 5, and 6. And the length is 4 meters, as you can see here. length is 4 meters. If this 10 kilonewton not here, all these other forces are 0 as well. Now, similar one, which looks like in the middle. So this is the one. You might need to rotate this one. Like if I use, I will just rotate this 90 degrees. So if I can draw it up here, that is the if I rotate this way, that will goes opposite. So if I rotate this way, if I rotate this way, then it would be P here. If I rotate these ones, it will goes P by 2 here, P by 2 here. You see what I'm doing, right? And L by 2, L by 2. And this guy is still going to push this PL on 8. And this guy still would be opposite of this one's PL on 8, right? So I hope it is makes sense. All right, so we're gonna match it these ones. In here we have a force going this way, which is P by 2. Force going this way, P by 2. We have force in going here, PL on 8. We have force going here, PL on 8. So P by 2 is quite simple, 10 by 2. So let's put it here, Q02. And near node is this ones. So we have 1, 2, and 3. And then 4, 5, and 6 far nodes. So number one is P by 2, which is 10 by 2, so 5 kilonewtons. Number 2, there is no any force in the number 2, you can see. So number 2 is 0. Number 3 is going positive, PL on 8. So PL on 8, which is 10 kilonewtons times by 4 meters over 8. This cancels 2, this cancels 5 kilonewtons meters. So that is number 3, positive 5 kilonewton meters. Same thing here. Number 4 is 5 kilonewtons. This one, number 5 is 0. This one is opposite, as you can see. This one is opposite, so minus 5 kilonewton meters. So if I sum them up, Q0, which has a big matrix with the 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we're going to match it up. Here we have 5 kilonewtons. Here 1 is 0. So 5 kilonewtons plus 0 is 5 kilonewtons. Number 2, we have 0. Number 2, we have 24 kilonewtons. 0 plus 24 is 24 kilonewtons. Then number 3, we have 5 kilonewton meters. And we have minus 16. So minus 16 plus 5. Minus 16 kilonewton meters plus 5 kilonewton meters, which gives me minus 11 kilonewton meters for number 3. Number 4, 5 kilonewtons. There is no number 4 here. So 5 kilonewtons for number 4. Number 5, there is not in the previous. Number 6, minus 5 kilonewtons. Number 7, 7, 8, and 9, 0, 24. 0, 24 kilonewtons and 16 kilonewton meters for number 9. Now, unmute yourself or put it in the chat if you have any questions getting Q equal to Q01 plus Q02. In fact, we have all the values now. So in that case, we just need to Q equal to KD plus Q0. We got this one. So now we need to put those values in our equation. So first of all, let's get the Q. And we got the Q before, right? I can show it to you again. That we got the Q here. There you go. I can copy that one. So 3 zeros, 1, 2, 3, and Q3, Q4, Q5, Q6, Q7, Q8, Q9. Right. Equal to capital K. We done it capital K in our Excel too. So here you go, capital K. I'm copying it from my Excels. So the Excel file that I got here, and from that Excel, so I'm copying 10 to power 6 times by this, and I can see that partitions here. That's I can put it here, and if I want to write 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in these partitions, we can draw the line from 3 as well. We don't need to write this one because we're not going to use it. If you are smart, then you can do it in your assignments or in your final exam. So it will save your time. So let's say 1, 2, 3, 4, 5, 6, 7, 8, and 9. So for this one not required. So 1, 1, we can have 511.25, 0, 22.5, 0, 511.25, minus 22.5, 22.5. And you know these numbers where it's coming from, right? By the way, we done both hand calculation and Excel. And this one is 11.25, 0 minus 22.5, 0 minus 500, 0, 22.5, 0, 30, minus 500, 0, 0, 0, minus 11.25, 22.5, 0, minus 22.5, and 30. This 5, 6. These numbers you can copy it, but we're not going to use it. So I just put the dash there. And from here, we can put D. D would be D1, D2, D3, 0, 4, 5, 6, 7, 8, and 9 are 0. Plus Q0. I think we just got a Q0. 524 minus 11. 5 kilonewtons. 24 kilonewtons. Minus 11 kilonewton meters. 5 kilonewtons. 0 kilonewtons minus 5 kilonewtons, 0, 24 kilonewtons, and 16 kilonewton meters. Right, so that is all your Q equal to KD. Now, first of all, we're going to solve D1, D2, and D3. So I can get the partitions just by taking this only. So that is 0, 0, 0, 0 equal to 10 to power 6. This 3, 511.25. 0, 22.5, 0, 511.25, minus 22.5, 22.5, minus 22.5, 120. I copied these three, these ones. I copied these 3 by 3. Then I copy D1, D2, D3 from this one. And then I copy this plus. I copy the remaining 5 kilonewtons, 24 kilonewtons, and minus 11 kilonewton meters. That's I'm going to show you here. Here, I copy it from here, those 3. Right, so our questions to find D1, D2, and D3. We can first bring this one across. So 0 minus 5. So that's become minus 5 kilonewtons. This one become minus 24 kilonewtons. Bring this one here, 11 kilonewton meters, equal to 10 to the power 6 times by 511.25, 0, 22.5, 0, 511.25 minus 22.5 minus 22.5, 120. And D1, D2, and D3. Now it is 3 by 3 matrix, so difficult to solve, but we can solve by, let's say this is A matrix, that is the whole thing is B matrix, and this is the, let's say, X matrix. So if I do B inverse A equal to B inverse BX, like I multiply B inverse both sides, so that's cancel each other. So I can get B inverse A equal to X. So we can use the Excels to get this B inverse. We do it Excel's on that end. So let me get these ones here. Excel's we have this 3 by 3 matrix. That's we need to inverse it, right? So this 511 and this ones. So if I just take these ones, copy and put it here, just number it. I just want number. Just a value. Yep, that's just value. And I don't need any background, no filling. So this is our matrix. I think I hope you can see these ones. It's not popping it up here. It is. So as you can see, 511s and all. So we want to find this is the B matrix. So by the way, this is your B matrix. And we need to find the B inverse. We need to find a B inverse for these ones. B inverse for these ones. So I think you remember that equal to, I think we just need to select all 3 by 3 like this. And here equal to M inverse. M inverse INVERSE. M inverse, and then you select from here to here. Bracket over, and there you go. That is your inverse matrix, right? Very small numbers, but anyway, this is how it is. So that is a inverse matrix. So let me check the numbers here. 511 0 22.5, 511 0 22.5, 0 511 minus 225. This one's 225, 122.5, 120. That is perfect. Now, so B inverse is done, and then next to it we need to multiply by A. So there is a matrix A. We can just write a matrix A here. Matrix A minus 5, minus 24, and 11. Minus 5, minus 24, and 11, right? So we need to multiply this B inverse. We need to multiply B inverse times by this A. Okay, so that's A. So I think the way it can be done, I think it's gonna go the 3 by 3 matrix. So we can put it like this. You know the story, right? 2 1 1. Here you go. K2 1 1. So here you go. We can do it. EL on just watch me. AE on L. Let's cancel these ones. Bracket AE on L times by lambda X. Oh, K2. Oh, sorry. K2. So AE on L times by lambda X square. So lambda X square plus 12 EI on L cubed plus 12 EI on L cubed times by lambda Y square. So lambda Y square. And your lambda Y is negative square, so that become positive. So you got 11.25. And what about our hand calculations? K2, K1, K2 11.25. 11.25 because you have AE on L and lambda X is 0. So this guys is 0. This guys is completely 0. 12 EI on L cubed. What we calculate 12 EI on 11.25. So that's value is 11.25 times by 10 to the power 6. And then times what is lambda Y? Now lambda Y is minus 1. So minus 1 square. So that will give me 11.25 times 10 to the power 6 positive. Where are we now? OK, yes. So multiplications, you know these rules, right? Because this is the B inverse. We got the B inverse. We got the B inverse there. B inverse, it is a 3 by 3 matrix that we got, and that is already given in the Excels. 3 by 3 matrix. And then you have A matrix, which is minus 5, minus 24, and 11. So that is 3 by 1 matrix. So if you this these numbers and these numbers are same, so multiplication is possible. But the answers would be 3 row and 1 column. So if you multiply B inverse with A, your answer would be 3 rows and 1 columns, right? Because these numbers, which is 3 rows, so 1, 2, and 3 rows and 1 column. So that is 1 column. So that is, so it is like that. So we can just have a 1 row, 3 columns equal to M matrix mult brackets. It's asking me the first array, so that is your first array, comma. It's asking me what is your second array. This is my second array, comma, finish, enter. So that's all you get. 1 point, very small numbers. Let's check it out. Inverse of the matrix, and that is your answer. So I'm going to copy these answers answers here. So our final answers would be bracket D1, D2, and D3 equal to, by the way, we can just copy these ones here. And then we just write it. Okay, that's here. So let me go back here. We got, yep, that is popping it up. So that's nice. 1 minute, please. You finished? Yeah, I've been done. Yeah. Yeah, swear me there. I was ready the that's about good. I kind of left up one more. Yeah. It's actually Friday, I'll just these. Okay, yeah, they will send it. Yeah, they'll send it, so it was straight to, yeah, it's gonna take people to start working again. Check that, okay, I'm okay. Yep, yeah. I'm pretty confident. Very good. All right, nice, thank you, yeah, see. All right, sorry about that. There is someone knocking on the door of the office, so that's all good. So we got all these D1 and D2. Now we can put these details here. It is minus 1.35 times 10 raised to minus 8, and it is minus 4.31 times 10 raised to minus 8, and it is 8.61 times 10 raised to minus 8. So it's basically D1, D2, D3 equal to 10 to the minus 8 minus 1.35 minus 4.31, 8.61 meters. So this minus sign indicate that nothing wrong with our answers. This minus sign indicate that our displacement will be opposite to what we have assumed, meaning that if you look at these figures here, what does it means? Let me copy these figures and coming down here. In here, so you can see that this displacements in the one, so that is displacement D1 here, that is going to be happens this way. So this point going to move this way by minus 1.35 times 10 raised to minus 8 meters. So that was minus because it's opposite to this one. Number two, you get displacement going in this direction, this point. By the way, this point is going to go down by minus 4.31 minus 10 raised to minus sign is indicating down meters. And this point will rotate in the same direction because it's positive. That rotation is 8.61 radian. So I hope it is 10 to the minus 8 radian. I hope it is makes sense to D1, D2, and D3. Any questions there? Let me check. They're getting this one instead of this one. Done. Okay, so that is the questions from the previous one. So this is all good. Now D1, once you find the D1 and D2, we can get this Q3 to Q9, and we got this one here, and we grab that one. So let me write it up. So Q1, sorry, not Q1, Q3. So let me write it up. Q3, Q4, Q5, Q6, Q7, Q8, and Q9. Is it correct? Oh, Q4, starting from Q4. Right, and then you have 10 to the power 6, and we gonna get these values here, all these values here, minus 11.25, minus 11.25, zero, minus 22.5, 0, minus 500, 0, 22.5, 0, 30, minus 500, 0, 0, 0, minus 11.25, 22.5, and 0, minus 22.5, and 30. And then you have D1, D2, and D3. That's we're going to plug the value. Minus 1.35 times 10 raised to minus 8. Minus 4.31 times minus 10 to 8. 8.61 times 10 raised to minus 8. And then you have plus, you have those 5 kilonewtons, you have 0, minus 5 kilonewtons. I'm going to show you where all these coming from. 24 kilonewtons and 16 kilonewton meters. So I take all this from our equations. We take, oh, this not Q3, there is a Q4 only, because this is 1, 2, and 3. So Q4. We take all these. We take all these ones with 10 to the power 6. We substitute D1 and D2, and then we do plus. We take this one all. So I hope it is clear here for you that to take all these values. Now, to get the now to get these ones, probably we can change these ones to we can change this one to 13.5. Let's make it minus 13.5 times 10 raised to minus 6. Let's make 40 minus 43.1. I hope you understand that. 43.1 times 10 raised. I'm just moving it this one so we can write it in that format. And let's put 86. 80.1 10 raised to minus 6 radian, and that is meters, and that is meters. Now, once you done these ones, we can just simply comment this one out, and probably we can write these ones in that format. So because 10 to the power 6 and all these cancels. So Q4 equal to this minus 11.25 times by minus 13.5. These ones plus 0 times minus 43.1 plus minus 22.5 times 86.1. All these ones plus 5 kilonewtons. That's coming from here. We might need to convert this one into newtons because we are working on the newtons. So let's put this one 5,000 newtons multiply by thousands. So let me use my calculators. Minus 11.25 times by minus 13.5. This one, by the way, 0 plus minus 22.5 times by 86.1 plus 5,000. You get 3,215 newtons, which is 3.2 kilonewtons. So that is Q4. Q5, we get this one 0. So 0 times minus 13.5 plus minus 500 times by is 40 minus 43.1 plus this one 0. So 0 times 86.1 plus there is a 0 here. So there is a 0 here. So this one whole thing 0, this one 0, and everything 0. So just 500 times by 43.1. You got 21,550 newtons. So we got 21.6 kilonewtons. Q6 Q6 here 22.5 times by minus 13.5 plus 0. So 0 don't count. 0 times minus 43.1 plus 30. So 30 times 86.1. And then you have this one minus 5,000. So minus 5,000 newtons. So let's put minus 5,000 newtons. So 22.5 times by minus 13.5. This one's 0 plus 30 times 86.1, take away 5,000. So you got minus 2720 newtons. So it will be minus 2.7 kilonewtons. Q7 here minus 5,000. Or we have Q7, which is 5,000. Sorry, 500. This one's times by minus 13.5 plus 0 and 0. So that is 0 times minus 43.1 plus 0 times 86.1. And then finally you have 0 here. So that is 0 here. So this whole thing 0, this is 0, this is 0. So only 500 times 13.5, that makes it positive. 6750 newtons, which is 6.8 kilonewtons. Q8 equal to, there you go, 0 times minus 13.5 plus minus 11.25 times by minus 43.1 plus 22.5 times 86.1, and you got 24 kilonewtons. So that would be 24,000. So just change it, this one's to 24,000 newton. So plus 24,000 newtons. So in that case, this whole thing 0 and minus 11.25 times minus 43.1 plus 22.5 times 86.1 plus 24,000. You got 26,422 newtons is equal to 26.4 kilonewtons. Q9, last one, 0 first, then second one minus 22.5 plus 22.5 times by, that is minus, and minus 43.1. Minus 43.1 plus 30 plus 30 times 86.1 plus 16,000 Newton millimeters. So plus 16,000 Newton meters. So this one 0 minus 22.5 times 43.1 minus plus 30 times 86.1 plus 16,000. you get 19,552 Newton meters. So that will be 19.6 kilonewton meters. So I hope you understand these ones. As you can see, these figures that's here. Let me copy that figures for you. And then we're going to put all these details, all the reaction forces on that figures. Now, let's start with Q4. Now, the Q4 that we got is 3.2 positive. So Q4 we got 3.22. So in here, you can see Q4 is going this way, and that is 3.22 kilonewtons. Right? I hope it makes sense. Q5 21.6. So Q5 in here, that is number 5, you can see, and Q5 is 21.6 kilonewtons. Moment 6. So moment reaction 6, 2.7 kilonewton meters, which is negative. So if you get the negative answer, does not need to do anything. You just need to put the opposite of these ones. That's arrow coming this way. So it is 2.7 kilonewton meters. Now Q7 6.8 kilonewtons. So Q7's going this way and 6.8 kilonewtons. Q8 26.4 positive answers. Don't hesitate if you have positive or negative answer. Positive answers meaning that these directions that you assume is same as these ones that you found. So 26.4 kilonewtons. And the last one 19.6. So that's basically these directions. This one is 19.6 kilonewton meters. So that is all these are putting onto the diagrams. I hope it makes sense. We are solving this example, so let's get on to it. We have fixed supports, fixed support, young modulus, area, and everything is given to us. So let's put this one. So it is 4 meters and then coming down to 4 meters and 2 meters and 2 meters. So we're going to draw 4 meters. I think this one draw members 0 and then 4 meters and then coming down to 2 meters and 2 meters. Right, so that is your 4 meters and 2 meters. And then from there, you want to put the boundary conditions. So if you double click on this one, this is fixed supports, click OK. This is fixed support, double click, and this is fixed supports, click OK. And if you want to show that boundary conditions, you can show that node constraint. Single click, and then you can go to the UDL load. And from that UDL load, we will have a how much it is? It is 12 kilonewton per meter. So put minus, so that shows that it is coming down. Minus 12 and minus 12 finish. So you can have this minus 12. So if you want to show diagram annotations and hit OK, so you can see minus 12. You have another loading which is 10 kilonewtons coming this way. So single click on here and 12. How much was that? 10. OK, so X is minus 10. Hit OK and hit OK. So that's you can see. If you want to just correct this ones, that would be good. So if you can just correct going this way, that would be good. Probably there is some check these corrections. Q6 10 to the power 6 22.5 and multiplications. If it comes negative, you put the opposite direction to this one. If it is come positive, you put the same directions. But you got a concept, right? Make sure you check it. you got the overall concept, does it? And questions, we are working on the space gas, we put the loading, we put those things and so on. Now, these ones, we can put any dummy cross sections, let's say universal. You can pick anything that you like it. I put it here. You can put the materials, let's say steels, and put it here. It's like this. OK, now in our lecture notes, there is some values given to us. That's we're going to use it. Now, first of all, let's do the Young modulus 200 gigapascals. Now, Young modulus is given as a 200 gigapascals. That is given in our questions. Now, the space gas softwares require Young modulus in megapascals. As you can see, that's required in megapascals. So that's we need it in the megapascals. We need it in the megapascals. We can't use it in the gigapascals. That's fine. So 200 times 10 to the power 9, that is giga and pascals. Then you can say that 200 times 10 to the power 3 times 10 to the power 6, that is become 10 to the power 9 pascals. These things, 10 to the power 6 is a mega. So 200 times 1000, 10 to the power 6 is mega, and this is pascal. So 200,000 megapascals. So 200,000, that is perfect. That is still. So 200,000 is correct. Now, seconds, we have given area 10,000 millimeters square. We have given area 10,000 millimeters square. That's the area given to you. Now, what we need in this ones, we just need in the millimeter square. So lucky enough, so we put 10,000 in here in area. Probably we can put 10,000 here as well to be on the precise. So that is all good. 10,000 given to us. What else given? We have given I 3 times 10 to the power 8 millimeter power 4. So that's I is different. So 3 10 to the power 8. If you want to do it, then you put E and 8. Right. So I hope you understand 3e to the power 8. So like this ones, that's given in I given in the question was 3 times 10 to the power 8 millimeter power 4. Millimeter power 4 is correct, but to put it into the space gas, you need 3e8 millimeter power 4. So you can type these ones in the space gas, which is 3e8 and 3e8. So that's all I values. Area, we put it, we put Young modulus. So 3 things we need in the space gas. Area in the millimeter power 4. We need the millimeter power square. Let me erase that. We need it in square. We need the I in the millimeter power 4, and we need the Young modulus in megapascals. There are 3 things we need to input. First, you plug in with the library, and then after that you do it. After that, we do it with those ones as well. What happens here? Anyway. Yep. So this not go through it. Let me do it here. Universal beam, any beams. Area is 10,000. This one is 10,000. 3e8 and 3e8, and materials is steel. So that's all good. 200,000. Okay, that's all good. Now we run analysis, linear static analysis. Hit OK. Yep, that's completed. All right, first of all, we're going to check the reaction forces. So let's check the reaction forces. Let's turn off all this loading. And that's reaction forces here. So this one going, Mira, please check it. This one's going this way. And that is 2.72 going this way. So how about these ones going this way? So it's wrong here. In my hand calculation is correct. You can look at the space gas, right? 2.72 and is positive, I believe. I can see is positive. Oops, sorry. I can see is positive and it's going this way 2 point, or it is negative. We need to get from the report. If you can't read it here, you can get the tax report and the next and hit OK. I think it will generate the tax report, and from this tax report, node restraint and node displacement and reaction. So yeah, so that's node number 4 has minus 2.72, right? So that is minus, meaning that I think therefore they change the direction. So I hope they clarify these ones. 21 point in our hand calculations. We want to verify with our hand calculation 21.6. Let me put the green smiley face. 21.6. 3.21. Yeah, 3.21. Again, smiley face here. 3.21 we found. Q6 minus 2.7. Yep, from the report we found minus 2.7. So again, the smiley face here. We found Q7 6.8. Q7 6.8. That's going this way. That's perfect. Very good. 26.4. 26.4 going up. That's perfect. 19.5 going this way. 19.5 going this way. Some minor errors due to the rounding errors. Okay, so we verify all the reaction forces. Now we can also verify our displacements. Now D1 that we got is D1 we got here was D1 we got minus 1.35 times 10 raised to minus 8 meters. Minus 8 meters. So if I multiply these ones by thousands, I will get in the millimeters. 1.25 times 10 raised to minus 8 times by thousands. So to get it into the millimeters. So let me do it. 1.35 times 10 to the power minus 8 times by 1000. You get 1.35 times 10 raised to minus 5 millimeters. Right. So let's get space case to give us some value. Let me turn it off these reactions and get the displacements. Look at that. X displacements is almost 0.01. So that is 1.35 millimeters. That's you can see there. 10 to the minus 5. Probably there is some off of the units. Then we will have a y is 0.04, so that is 0.04 looks very similar. And 8.61, I think we need to get this one from the report because rotation is not shown here. If you go to the output and text report, you might get some values for the, if you go to the displacement, node restraint, section property, material property, node load, material distributed force, node displacements, Z. So I think there is load case 1 linear minus 4 0.03. So now I think rotation is not member force and moments. No, they're not showing it. Node reactions are there. Bill of materials. Now there is nothing for the rotation anyway, but others details are already verified, so the rotations would be okay. You can say that all the reaction force are verified, all other displacements are verified. So and paste. So this is your questions. Okay, now to find the capital Q0, that is the students ask me, that is looks a little bit confusing. So Q equal to could be Q01 plus Q02 plus Q03 plus Q04, depending on how many members you got. Now here, how many members you got? Can you please tell me the answers? How many members do we have in the questions? You can start answering me the questions, so I will watch it here. How many members do you have in these figures? No questions? Yep, 2. So that's all good. So you with me to say that Q01 plus Q02, right? You with me to say that this is Q01 plus Q02. Now, so Q01 is belongs to member number 1. Now, member number 1, if I draw the member number 1 exactly, what was shown in the questions, that is these lines, I draw it, these lines here. These points here, these 2 dot points, I draw it up here. In these ones, I can draw 7, 8, and 9. So 7, 8, and 9, that is degree of freedoms. And I can draw 1, 2, and 3. Just copy paste. Nothing I done uh, important here. 3. Right? So far, so good. And the length is 4 meters. So the length is 4 meters. Any questions in this ones drawing up here? Any questions there? Okay. Any questions in drawing these figures? That any numbers that does not make sense? All good? Do you have any questions in this one to draw these members that which I draw it here? All good, no questions. So for that, if you have no questions, you're happy for me to put these 12 kilonewtons meters here as well. So let me put this. Twelve kilonewton per meters. So far, so good. Now we can go back to our lecture notes, and in our lecture notes, slide number somewhere, you can find this figure. And I can open up for you to show it to you, this one. So there you go. You can find this figure somewhere in your lecture notes. Right, you can match the figures. So these figures are matching with these figures. Do you understand that? Now for that case, you might be able to write this vertical force, which is WL divided by 2. This vertical force is WL by 2. This moment would be WL square on 12. And this moment going this way, WL square on 12. So far, so good. Any questions? Anything that does not make sense? You can, if you question me right now, then the others would be easy. If you have any questions, we can solve it here. I think so far so good. It makes sense, I believe. Now, In here, we have WL by 2, right? So if I want to calculate WL by 2, so 12 kilonewton per meters times by length is 4 meters over 2. So this one cancels 2. So this would be 24 kilonewtons. Similarly here, I can write 24 kilonewtons. For these guys, I can have 12 kilonewton per meters times by 4 square meter square over 12. So that's 12 cancels, only 4 square left, which is 16 kilonewton meters. And similarly here, that would be also 16 kilonewton meters because the same equations. Do you have any questions there? Do you have any questions there? No questions? So I can write Q01 equal to, for these frames, we would have always 6 rows and 1 columns. Now, this arrow that is given in our questions, that arrow telling me that is your near node. This is near node because it's a tail, and the head is a far node. So you need to look at the near node first. So that is your near node. Near node X is 7, near node Y is 8, and near node rotation is 9. So that is your near node. So this is your near node, and that is X, Y, and rotations. Now you can look at the far node. Far node has a 1, 1, 2, and 3. So 1, 2, and 3. So this one is your far node. And for this far node, this is your X, Y, and rotations. Right? So far, so good. Now you can come back here and look at the 7. 7, there is no any force going on the 7, so that is 0. Look at the 8, arrow going up, number 8, arrow going up here, the force, and 24 kilonewtons, both going in the same directions, 24 kilonewtons, so positive is going up. Number 9, look at the arrow for number 9 going this way. Look at the arrow for these ones, WL square on 12, both going in the same direction, and the value is 16 kilonewton meters. So 16 kilonewton meters. Number 1, let's go here. Number 1, there is no any force in the number 1, so that is 0. Number 2, going up, and that is also going up, and it has a value of 24 kilonewtons. So 24 kilonewtons. Number 3, we have going this way, and this one's opposite to number 3, which is 16 kilonewton meters, which is minus 16 kilonewton meters. Right? So far, so good. Any questions there before moving on to the Q02 sections? Okay, so far so good. Now, yep, no questions so far, so all going well. So now we do the Q02. Now for Q02, we're going to look at the member number 2. And if you look at the member number 2, which are shown here, let me get this member number 2 somewhere close so we can clearly see it. Okay, so that is a member number 2 here. Now let me draw up the member number 2, that line here, that line I just draw it here. Then I can draw these 2 dots. Let me draw these 2 dots. From here, I can draw 1, 2, and 3. So I can draw 1, 2, and 3. I can draw these 10 kilonewtons. So that is in the middle, 10 kilonewtons. I draw 4, 5, and 6. So I can draw 4, 5, and 6. Right? So that's all. So far, so good. The length of this one is 4 meters, as you can see there. Now, from here, I need to match these figures because you have 1 and 4 going in the middle. So I cannot see these ones. This one is some distance A and B to different. I can't use this one. So I can't use this one. Only candidate left is this one. So if I rotate this one, if I draw this line like this, if I draw this horizontal line to the vertical line, I can see this one. So you can see this one. This vertical line, which I'm going to draw it here in the middle, which is P. These lines that goes opposite to the P. This line goes opposite to the P by 2, opposite to the P by 2, because this one down, this one up, you can see. So that's I represented that one. These ones is you can see this one is clockwise. So if I put these ones here in these directions clockwise, and in these directions this one's anti-clockwise. So I can put this one anti-clockwise. Right? You can see this one anti-clockwise, and this one clockwise. So I put this one clockwise, this one anti-clockwise. I hope it is makes sense. So this one I draw it up. Now here I can put the same thing, that is P by 2 opposite to that one. Then you have clockwise, which has a value of PL on 8, and it has this one is anti-clockwise. This one has anti-clockwise, PL on 8. Right, so the green one that we're going to get it, P by 2 is equal to 10 kilonewton by 2, which is 5 kilonewtons. This one here, again 5 kilonewtons. PL on 8, which is 10 kilonewtons times by length 4 meters over 8. So that will cancels to, which will be 5 kilonewton meters. And this one also 5 kilonewton meters. So the Q02 you going to get is with the same philosophy, saying that we have this arrow. This arrow is telling me this is near node, this is far node. So this one is near, this is far. So first we're going to do the near one, and near has a x1, y is 2, and 3 rotation. So no, sorry, 1, 2, and 3. That is what? That is your near node, and near node x, y, and rotations. Similarly, we can get the far node. This head is telling me far nodes, and this far node has 4, 5, and 6. So 4, 5, and 6, and again 4 is x, y, and rotations, and this is far node. Same like we done it for the Q01. Now go back to our figures. Number one is going this way, P by 2 going this way, and the value of 5 kilonewton, both going in the same direction, so take it positive. Number 2, there is no any force in the number 2, so that is 0. Number 3 is going this way. You can look at the original figures as well along with these ones. Number 3 going this way, which is anti-clockwise. This is also anti-clockwise, and the value for this one is 5 kilonewton meters, same directions. So we have positive 5 kilonewton meters. Number 4, there is a force going this way. Force is going this way, 5 kilonewtons. So both are positive 5 kilonewtons. Number 5, there is no any force in this direction. So number 5 is 0. Number 6 is opposite to this force, which is 5 kilonewton meters. So you have minus 5 kilonewton meters. Right. So once you got these small q01 plus small q02, which I'm going to copy it here for you. So which would be 0 minus 0 24 16. 0 24 kilonewtons 16 kilonewton meters. And then you have 0 24 and minus 16. 0 24 kilonewtons and minus 16 kilonewton meters. And for that, the 7 8 9 1 2 3. So we put 7 8 9 1 2 3 plus we have we have 5 0 5. So 5 kilonewtons 0 5 kilonewton meters. We have 5 0 minus 5. We have 5 kilonewtons. We have 0 and minus 5 kilonewton meters. So for that case, we have 1 2 3 4 5 6. So we have 1 2 3 4 5 6. So to get this BQ, we can make it 9 by 1 by 9, because total degree of freedoms that's in our question is 9. 6 7 8 and 9. 1 2 3 4 5 6 7 8 9, because you can see total degree of freedoms in our problem total is 9. So to do these ones, we have one 5 kilonewtons and one is 0. So 5 kilonewtons plus 0 equal to 5 kilonewtons. Number 2 is 0 and 24. So 24 kilonewtons plus 0 is equal to 24 kilonewtons. Number 3, minus 16 kilonewton meters plus 5 kilonewton meters equal to minus 11 kilonewton meters. Number 4, there is no number 4 here, so there is 0. But here we have 5 kilonewtons, so equal to 5 kilonewtons. Number 5, there is no number 5 here on the first one, but here 0, so both are 0. Number 6, there is no number 6 here, only this one, minus 5 kilonewton meters, so equal to minus 5 kilonewton meters. Number 7, 0, there is no number 7 here, so 0 plus 0 is 0. Number 8, 24. So 24 kilonewtons plus 0 is equal to 24 kilonewtons. And number 9, 16. 16 kilonewton meters plus 0 equal to 16 kilonewton meters.